Hello everyone, welcome to my YouTube channel Tech. This is the ninth video in the series of Python programming. So we have so far discussed numeric data types and sequence data types. And now we are moving to two special cases. One is Python sets, and the next video will be discussing about Python dictionaries. So what is a Python set? A set is a collection of unordered unique items written inside curly brackets separated by commas. So it is unordered and it has unique items. So let me clarify on that. So the term unique indicates that the duplicates are eliminated, right? So whatever the element inside the set, it appears only once. If there is any duplication, they are removed automatically. So let's demonstrate that with an example. So here I have given an example set. So as you can see here, it is written inside curly brackets and separated by a comma. Let me get to the shell window. Yeah, so I've already created a couple of sets. The set A is the same as what I have given on the slide, right? As you can see here, the number 1 is getting repeated 2 times and number 2 is getting repeated 3 times. Okay, now let us print this set. Now what happens is that the extra 1s and extra 2s are getting removed, right? And we are getting only the unique elements. So each element is unique. It's the repeating elements are taken care of, and it is unordered. So if you see the original sequence, so this is index 0, 1, 2, 3, 4. So the number 5 is appearing at index 4, and number 6 is like this is index 5, index 6, and index 7. So number 6 is appearing at index 7. See what here happens here. This is index 0, 1, 2, 3, 4. So 5 is appearing at the same location, but 6 is appearing at index 5. Initially it was available at index 7, and 4 was initially available at index 6, but here it is available at index 3, right? So because the duplicates are getting removed and the rest of the numbers are getting shuffled, so see 4 goes before 5 here, right? So there is no particular order that you can access the elements. So that is why it is an unordered unique set of elements, right? So coming back to our slide, so the same thing I've done here. So I missed out the 6, sorry about that. So the 6 should be coming here, okay? And since the elements in set are unordered, indexing has no meaning. So only if you have a fixed place for each element, only then you can go for indexing. But here the set, it is unordered, so you can see that the 4 gets shuffled before 5 and the duplicate elements are removed, so you cannot assign a fixed index for each element. So therefore indexing has no meaning in sets, right? So where is this set applied? Okay, so yeah, when you have a pretty large column of numbers and you want to remove duplicates, right? Then you can go for sets. Or if you have 2 columns of data and you want to combine them, like you want to find the intersection between the 2 columns, you want to find the common elements in both the columns, right? Then you can go for sets. So sets have a unique purpose like this. You can also use a set command to create a set. Let me demonstrate here. I can convert either list, okay, to a set. Okay, let me show you here. So C is equal to set of, I'm giving a list here, 1 2 1 2 3 4 3 4. Now if I print C, so it automatically creates a set, right? You can convert a list or tuple into a set using this simple command. Again, set can support any data type. For convenience I've used only integers here, but it can support strings or string as well, right? It can support floating point or complex, right? So that's your set. And some special operations are available with respect to sets, which you'll see now. Alright, let us go through this one by one. First one is an add command. So it's adds a single element to the set A. Okay, so we already have a set A. Let us add the number 7. Okay, so initially my set A, when I print the set A, I had elements up to 6, but now I have added an additional element 7. Now if I try to add multiple elements using a list, say for example 8 9 8, so what happens now? so it throws an error. So using add function, you can only add single element, a single number, a single data type, right? Numeric data type. If you want to add elements from a sequence data type, you can use the command update, right? Let me give the same thing, 898. So now the 8 and 9, so 8 is repeating, so the duplicate entry is removed, so 8 and 9 are added to the original list, right? So update, you can use it to add multiple elements from a list or a tuple to a set. So I have not mentioned update in the table, but you can take a note of it. And next one is clear. It removes all the elements from a data set. Okay, we have created a set C, right? So let us try to clear that. So C dot clear off. Now C is an empty set, so it can clear all the elements in a set. And A dot copy returns a set copy of the set. Okay, so let me say C is equal to A dot copy. So C now has a copy of the set A, right? And then we have difference, A dot difference of B. So read this carefully. Returns the elements of set A that are not present in set B, right? Okay, that means it returns the unique elements of set A. So if you consider two columns of data with numbers, and if you want the numbers, only numbers in first column, that does not appear in second column, right? You want only those numbers, so that is difference. Okay, let me give you a clear example here. So I have in A, set A, I have 1 2 3 4 5 6 up to 9. In set B, I have 1 2 3 4 5 6. So I want those elements in set A that are not in set B. So what are the elements? So B has up to 6. So the remaining elements are 7 8 9. So they are present only in set A and not in B. That is a difference. Now let me show you now a difference of B. So 8 9 and 6. Why is the 6 here? Oh, B has a 7. I'm sorry. B has a 7, but it does not have a 6, right? So 1 2 3 4 5 7 are present in B, but it does not have a 6. So 6 8 and 9 are unique to set A, so that is being displayed here, right? So that is a difference. And A dot discard, remove the specific item from set A. Okay, so like A dot discard of 9, let me say 9. Okay, so now if I print A, the element 9 will be there. Now there is also a function called A dot remove. Probably I mentioned in the table somewhere, so we'll check, we'll work it out now itself. So that will do pretty much the same. So why do we have two functions that performs the same task? The primary difference is that if I give a number that is not present in the set, then the remove function will throw an error, while the discard function will not. Let me show you. A dot discard of 10. So when I perform this, it does not throw an error. It looks for 10. If it is there, it removes it. If it is not, it just keeps quiet. But if I do the same function using remove, so what happens now? It will throw an error. It says that there's a key error. There is no 10. So that's the primary difference between discard and remove. So it is advisable to use remove because we need to know which elements are present or not present in the set. Right, and the next one is intersection. It returns the elements that are common to sets A and B. Right, let's see here. A dot intersection of B. As you can see here, A has numbers from 1 to 7. B has them too, but B does not have 6. Right, so except 6, as you can see here, B does not have 6, but it has all the other elements 1 2 3 4 5 7. So except 6, every element are present, so all those elements are intersection, right? There you go, 1 2 3 4 5 7. 6 is not there because 6 is unique only to A. Now the next one is union. Union returns a set containing the union of sets A and B, right? So it combines all the elements of sets A and B and removes the duplicates and presents them to you. So let's check here, A dot union of B. Now we get the 6 because 1 2 3 4 5 7 are common to both A and B. In addition to that, A is having a 6, so it combines that also. So union, basically it combines the elements in both the sets. So continuing further, the next operation is disjoint. Returns true if two sets A and B do not have an intersection. So in our case, A and B both have an intersection and they have 6 common elements. So if I use C is disjoint function, it will throw false. There you go. So false, because we have intersecting elements. Only if there is no elements common between that is common to both the sets, only then this will throw true. And A dot is subset of B returns true if all elements of set A are present in set B. Now that is not the case here. Like I said, the number 6 is unique to A. All the other elements 1, 2, 3, 4, 5, 7 are present in B, but 6 is not present in B. So A is definitely not a subset of B. So it throws a false. But the next one is superset. A dot is superset of B returns true if all elements of B are present in A. That is, B is a subset of A. In that case, this will throw a true. So that is true in our case, right? 1, 2, 3, 4, 5, 7. These are the primary elements in set B. They are also present in set A. So if I put is superset of B, that will give true, because B has 1, 2, 3, 4, 5 and 7, nothing more than that. All those values are present in A. So if you check A here, so all the values are present here, 1, 2, 3, 4, 5, 7. So A is definitely a superset of B, or you can say that B is a subset of A. Then A dot pop off, this removes the first element from the set. So let us try this. A dot pop, there you go. The first element is 1 here, so it has removed 1, right? Then the remove function we have already discussed. The last one is symmetric difference, returns a set with all the non-intersecting values of set A and B. Now A has 2, 3, 4, 5, 6, 7. We have removed 1, mind you. We have removed this 1. And B has 1, 2, 3, 4, 5 and 7. So 6 is unique to A and 1 is unique to B. So 1 and 6 are the non-intersecting elements. So let us try this. A dot symmetric underscore difference of B. So that will give me 1 and 6, because 1 and 6 are not intersecting elements. 1 is unique to A and 6 is unique 6 is unique to B, A, and 1 is unique to B. So this is symmetric difference. So these are all the important functions of sets. They can come in handy at many projects. For example, if you have a column of numeric data, you want to check the unique number of unique values in the column, or if you want to find the intersecting values between two sets of data. So for all those tasks, this set can come in handy. You can convert the column to a set, and then you can perform the set operations. So thank you so much for listening to the video. If you like the video, hit the like button, give your valuable suggestions in the comment section, and if you want more such videos, subscribe to my channel. Thank you.